Hello there, welcome back. This is lesson 4 in Unit 4, and today we're going to take a little bit of a break from conversions and talk about molar mass. So in the last video, we talked about the first of 3 mole conversions, converting between moles and number of particles. We're going to take a little break, go over today molar mass, next video percent composition, and then use that for the second of 3 conversions. So what we're doing today, vote on tomorrow, and will come in handy a few videos from there. Okay, so quick review. Here's a formula of glucose. How many C's, H's, and O's do we have? So you should say we have 6 C's, 12 H's, and 6 O's. Those are those little subscripts. Cool. So now we have 2 glucose molecules. So this 2 means we have 2 of the glucose molecules. So now, how many C's, H's, and O's do we have? Hopefully you said 6 C's, 24 H's, and 12 O's. So if you have a number, these are called coefficients. And when we talk about balancing equations, that's next unit, we need those. This means we have 2 of those glucose molecules, so 12 C's, 24 H's, 12 O's. Okay, next review question. How many M's, O's, and H's do we have here? Oops. M, O, H, and G, rather, sorry. We have 1 Mg, 2 O's, and 2 H's. Remember, this little 2 only refers to the parentheses. This means we have 2 of those parentheses, so Mg, OH, OH like that. So 1 Mg, 2 O's, 2 H's. Okay. And now we have 2 of the magnesium hydroxides. How many of each do we have? So we have 2 M's, 4 O's, and 4 H's. So now we have 2 MgOH OHs. Okay. So hopefully that is pretty basic review. So we're talking about molar mass. So let's go through these key points. The mass of 1 mole is called the molar mass. And so they are generally expressed in grams. And so sometimes you'll see it as gram formula mass, stuff like that. But it's all just talking about the same thing. It's talking about the molar mass. So the unit for this is grams per mole or grams over mole. And so, for example, 1 mole of nitrogen is 14 grams per mole. So what that means is that if you had 1 mole of nitrogen, so you had 6.022 times 10 to the 23 atoms of that nitrogen, you put all of them on a scale. The scale would say, hey, you got 14 grams. So having 1 mole of something doesn't necessarily mean you have a lot of something. I think a paper clip is about 5 grams. So if you had a mole of nitrogen, that's about 3 paper clips of mass. Okay. So, calculating molar mass, it is actually fairly simple. Let's get into this. So step 1 is list the individual elements, symbols found in the compound. So this is the compound we're going to be working with. We have K, we have Cr, we have O. Step 2 is figure out, well, how many of each do you have? We have 2 Ks, we have 2 Crs, and we have 2 Os. So then it says multiply the number of atoms by the atomic mass of the element. Now here, to save everyone some time, we can round to the nearest whole number, and then add the products. So we're going to look at the K, the Cr, and the O. So here's the little tiny formula. We have K atoms and the mass of K. So we have 2 Ks in our formula, and if you look at our periodic table to the nearest whole number, K is 39. So that means 78 grams comes from K. So now let's look at Cr. So in our formula we have 2 Crs, And according to your periodic table, Cr has a mass of 52. And so that gives you 104 grams. And so now we got to look at our oxygen. So we have 2 oxygens in our formula. If we look at the reference table around to the nearest whole number, you get 16. Means 32 grams come from oxygen. So what we did was find the part of each of those elements. And now we have to find the whole. So 78 plus 104 plus 32 gives you 214 grams per mole. So that means if you had 1 mole of K2Cr2O2, it would be 214 grams. Okay. So breaking up by each element, finding each part, and then finding the whole is my favorite way about doing it. And when we do percent composition, it makes that so much easier. Okay. So number 2, calculate the molar mass of Ba3PO42. So our formula is Ba3PO42. So we have Ba, we have P, and we have O. So look at Ba first. We have 3 of those in our formula. That little 3. Ba on the periodic table is 137. So if we have 3 Bas, each of which are 137, 411 grams come from Ba. We're not done. Gotta look at P. So we have 2 P's in our formula. Remember, this little 2 goes to both of them. So 2 P's. Look at the periodic table to the nearest whole number. P is 31. So 2 times 31 is 62. And then 62 grams of the total compound is 62. And then with oxygen, we have 8 of them in our formula. We have 2 of them, so that 2 goes to both of them. 8 oxygens. Oxygen to the nearest whole number is 16. 16 times 8 is 128. And so that's each of the parts. Not done. We have to add those all up together to get the total. And we get 601 grams per mole. Anyway, it's over here. 601 grams per mole. And that is it. That is all we had to do. Okay, so try this one. What is the molar mass of NO2? So we have NO2, you have N, and we have a different color, O. So with N, we have 1 of them. Nitrogen has a mass of 14. 1 times 14 is 14. With O, we have 2 of them. O to the nearest whole number is 16. 2 times 16 is 32. So now we found each part. Add them together. 14 plus 32 gives you 46 grams per mole. So 1 mole of NO2 is 46 grams. And that is it. Okay, try this one. What is the mass of 1 mole of CO2? So what is the molar mass of C6H12? I don't know if I just said that. I don't know what I said. Anyway, you find the mass of 1 mole or the molar mass of C6H12O6. Okay, so you'll get your final answer in a second. We have C, we have H, we have O. With our carbons, we have 6 of them. So the nearest whole number carbon is 12. 6 times 12 is 72. So 72 grams is carbon. H, we have 12 of them. So the nearest whole number H is 1. So 12 times 1 is 12. So 12 grams comes from hydrogen. And then oxygen, our formula, we have 6 of them. The mass of oxygen is 16. 6 times 16 is 96. So now we found each part, but we're not done. We have to add them together. So 72 plus 12 plus 96 gives us 180 grams per mole. And that's it. So we're really just figuring out how many of each element that you have, and the mass of each thing. Okay, so that was, I think, one of the shorter videos. Next video, we'll talk about percent composition. So we're just going to build on what we did in this video a little bit more. So make sure knowing how to do this makes sense. We will kind of go over it more, but we're going to build on this next video. So that is it for this. If you have any questions, leave them behind. Have a wonderful day. Bye.